So we're looking at patterns from complete graphs. So what does this mean? Complete graph, it means certain thing. I'll show it to you. So basically, we are taking up shapes and trying to see how they are related. That's what we're trying to do. So basically, how do the number of sides and lines connect non-neighboring points change as we add more dots to a shape? I'll explain this. So basic idea is by symmetrically connecting different number of dots, we can observe distinct patterns in numbers of sides and the lines connecting non-neighboring points. This reveals both direct and indirect number relationship. So basically, again, we are telling that, you know what, one shape to another shape, there's certain relationship, and this relationship is might not be as simple as a simple straightforward, looking at the number, you can tell it. It need not be that. It can be something complex, but by actually going and studying the shapes, you'll get to understand and make things a lot simpler. Whatever I just told in the last 1 minute or a minute or two, you will be able to understand by doing this particular activity. Okay, let's start off with this. Material, we need a pen and a paper and a ruler. I can't tell ruler properly. I think I did. Scale, basically. The procedure is quite simple. Here, you guys need to read the procedure and do the needful. So pause and try. Okay, let's start off. So first thing is to draw 2 points and connect them. And the question is, can we make a closed figure? This is not a closed figure. I'll explain what's a closed figure if you guys don't know this. So this is 2 dots. Then let's move on to 3 dots. I can put it anywhere, anyhow I want. Draw 3 dots, connect them with a straight line. Okay, connecting them with 3 straight lines. Form a closed figure. This is a closed figure. Okay, closed figure is you have a boundary within and you don't have a place to go outside. If this was a big compound, you won't be able to jump out. That's a closed figure. There are more definitions to it, but that's the simplest way we can define. But when it comes to 2 dots, you can go from here till here and so on and so forth. You can go everywhere. But with closed figure, if you are inside, you can't go outside. If you're outside, you can't go inside. Basically that. Next, 4 sides. So again, 4 dots. This is a quadrilateral. So connect them, count the sides. Oh yeah, sides, number of sides. Over here is 3. Number of sides over here is 4. And sides over here is none. Because there's no closed figure, right? 5th, I'll do it over here. This is your 5 sides, right? Sides is 5. Okay, looks good. Count the sides and non-neighboring lines. Oh, also, okay, I'm just doing one part. So we have to look into non-neighboring. So is there non-neighboring side points over here? Count the sides and draw lines connecting non-neighboring points. So are there non-neighboring points over here? Let me explain with this, right? 4 sides, quadrilateral. If I name this as A, B, C, D, A is neighboring to B and D. A is a neighbor to B, A is a neighbor to D. Is A a neighbor to C? Is it next to it? No, right? There's no direct line connecting and forming a side. It's not so. So here A and C are, let me take some. A and C are non-neighboring. Okay, guys, that's the basic idea of non-neighbors. They're not neighbors basically. Neighbors, so you understand, na? They're not neighbors basically. A and C are not neighbors. So similarly, if I name this as A, B, C, D, and E. So point E is neighbors to A and D, but not to C and B, correct? C is neighbor to D and B, but not to, correct, A and E. So they are not neighbors. Okay, let that sink. Now go to the figure, go to your triangle. My question is, are there neighbors over here? Yes, A has a neighbor of B and C, C has a neighbor of A and B has a neighbor A and C. Are they non-neighboring points? So non-neighboring points is no. No neighboring points. Or let me write it as no neighbors actually. That will be better. There are no neighbors. What about here? There are A and C, B and D, they are not neighbors to each other. So the statement tells that we need to connect them. Draw lines connecting non-neighboring points. So right, and also over here non-neighboring points. Am I done? Everything possible? No, right? B and D are not neighbors. We need to connect them also. So let me do that with so these are all your non-neighboring points. So let's count that, connect and count the sides and non-neighboring lines. So non-neighboring sides, there are two of. Here non-neighboring sides, there are, this is 1, this is 2, this is 3 and this is 4. This is counted. This is not counted. 1, 2, 3, 4, 5. This is counted, this is counted, this is counted. I think I didn't miss anything. 5. 1, 2, 3, 4, 5. Okay. Now pattern we observe. First, the number of sides. 2 dots has no closed figure, while 3 has 3 sides, 4 has 4 sides, 5 has 5 sides. So basically, our observation is that number of side in a closed figure, if formed, right, condition is if it forms, equals to the number of dots. And these dots are known as vertices. So here, there are 5 vertices. Okay. So there are 5 vertices. All these terms will help you in the future. So I'm slowly introducing them. And they are A, B, C, D, and E. Now, line connecting non-neighboring points. So when it comes to 3 sides, right? 3 sides over here, you can imagine there are no non-neighboring. All are neighbors to each other. When it comes to 4 sides, there are 2 lines connecting non-neighbors. Okay. 4, there are 2. 5 dots, there are 5 lines. 6 dots, there are 9 lines. Here, can you, as simple as this, can you tell 3 and 3, 4 and 4, 5 and 5? Or is there a simple relationship over here? No, right? So the number of lines connecting non-neighboring points, I'm misspelled over here. This is not our spelling. So everywhere the neighbor spelling is wrong. So non-neighboring points increases in a non-linear pattern. So not a constant increase or decrease. We're not seeing that. Okay. So to conclude, number patterns can arise from different aspects of shapes. What we're trying to tell here is the numbers that pops out of shapes need not be Sida Sada. It need not be straightforward. It can be complex. Sometimes it's straightforward, sometimes it is not. That's all we're trying to understand over here. Nothing complicated. All I'm trying to expose you guys to this fact that patterns can arise from shapes, and the numbers that pop out from all of those relationships, when you look at it, it need not be a simple straightforward thing. Sometimes it is, sometimes, and many times actually it is not. So example, a direct relationship exists between number of sides and the number of dots. While when you're talking about non-neighboring lines, indirect pattern, right? It is calculated with this formula. So what is this formula and what does it mean? What does this mean? We'll understand in time. Okay, throughout the year and the next year also we'll understand this. But point is, it's not a simple straightforward relationship. Basically, patterns may not be easy to spot unless we understand the main idea behind it. So this is the key thing that we are trying to understand. So basically what all of this tells us, keep your mind open to possibilities. This is very important throughout your life. Even as of now, I keep my mind open to hear from my own students, hear from you guys as well, in time, hear from elders and youngsters. Only then you will grow as a person. Only then will get smarter. To keep your mind open to new ideas and thoughts. That's all its education is about. Okay, so there are many possibilities and not everything we'll know, and not everything we can know. That's why we have to listen to others. We have to make decision by taking into quite a few things into account. Only then we should make decisions. We can't be adamant or we can't be jiddi, about certain ideas and thoughts that we have. I think I pronounce it right. Ziddi, I guess. Jiddi. You guys can correct me on that. Okay, coming back. So we looked at shapes can have patterns, and we started off with a simple one in the last video, and we went on to see that the same structures can also have a complicated relationship between them, and it need not be simple and straightforward. This means non-neighboring sites. Actually, it can't be sides, it has to be length. Non-neighboring length. Or non-neighboring lines is a better word.